Scientific measurements and tools. Let's begin by talking about why are measurements so important. So science relies on accurate and precise measurements, but so does other things that are really important. Cooking, fixing things, buying furniture that actually fits into your house and your space, reading weather reports, and taking medicine. Without measurements, life will be a lot more complicated and uncomfortable. First, let's talk about how do we measure temperature. So there's two different ways to measure temperature. The first being in Fahrenheit, and we use this in the US, and the other being Celsius, and that is used in science and most other places abroad in the world. Water boils at 100 degrees Celsius, and this is something I want you to memorize, but it boils at 212 degrees Fahrenheit. Water freezes at 0 degrees Celsius, but that is 32 degrees Fahrenheit. In our class, we're only going to be talking about using Celsius because that is a scientific measurement. Let's take a close look at this chart here. And we're going to talk about measuring length now. So there's two types of systems for measuring length. There is the metric system and the imperial system. The metric system is used by almost every country in the world, but the US. It's based on units of 10, which makes everything super easy to convert between different sizes. For example, 1 meter equals 100 centimeters. 1 liter equals 1,000 milliliters. And it's used in science, medicine, and sports because of how simple and universal it is. The imperial system is a lot more complicated though. It uses different units for each type of measurement. So this includes inches, feet, pounds, and gallons. These units do not easily convert. For example, 12 inches is 1 foot, but there's 3 feet in 1 yard. There's 16 ounces in a pound. It's a lot harder to keep track, and you have to do a lot more memorization for it to make sense. So why do we still use the imperial system in the United States? And here's where I go on a little mini history tangent. It started with the British, right? The British, here's what had happened. They brought over the imperial system to the US before the American Revolution. And you should know this in US history because y'all be listening. By the time the metric system started spreading in Europe in the 1700s, the US has already built roads, they already had tools, they already started publishing books with recipes using inches and pounds. So they were like, I'm not going to change everything. Changing everything will be too expensive and complicated, and we already started using it, so let's just continue going. And in the 1970s, when the US government did try to switch everyone to the metric system, it didn't stick. People were already too comfortable with what they know and decided not to change. But why does this matter to you? You're going to see both systems in real life. So, for example, if you travel abroad, you might see road signs that shows kilometers per hour. But if you don't understand what kilometers are and you're driving faster than the speed limit, you could be arrested, be put in foreign jail, and, your life is done from there. That's not what we want. We want you to go abroad and be a well-informed, more adaptable, and ready for the real world. Now we're going to talk about measuring length and, again, using that metric versus imperial system. So, in science, we use centimeters and meters. In our class, we will not be measuring in inches. Some real life examples is, let's say you also try to buy clothes from abroad. So one of my favorite stores is from Europe, Opoly. They only have clothes in these centimeters. H&M also, I believe, does a lot of sizes in the European. They use centimeters for the waist. So here's how you measure. You want to make sure you start at 0 and you use the side with the smaller numbers. If you notice, oh my God, there's a lot of gaps between each of the numbers, you are using the wrong side. Make sure you measure in centimeters. All right, now we're going to discuss mass versus weight. So there's a big difference between them, and sometimes people use it interchangeably. But mass is how much matter is in an object and it never changes. If you go to the moon, your mass stays the same because you're made of the same stuff. But if you go to the moon and you take your weight there, you're going to weigh a lot less. That's because weight is the force of gravity and it's pulling on that mass. So on Earth, the gravity is much stronger than the moon. And so you weigh more here on Earth. Let's talk about how we measure volumes and how we measure liquids. So we measure liquids using volume, and volume is also another thing of how much space something takes up. It is a way that we measure matter. You've seen volume in cooking. You've seen it in gas stations. You've seen it in science labs. It's very important because if you're going shopping for a hair product, you could become a smarter shopper if you understand, oh, this one is giving me 1 gallon, but this one is giving me 20 milliliters for lotion or whatever. It just helps you understand what you're getting out of things a lot better, and you can save money. Who doesn't like to save money? Lastly, these are some of the tools that you should know for lab and real life. We will probably be using a thermometer, a ruler, or a meter stick. This one is the electric balance. I'll teach you how to use that a little bit later. And this is the graduated cylinder. And finally, the stopwatch. This may be a chart where you have to know for your exit ticket.